Good morning or good afternoon to everyone. We will just wait a couple of more minutes to allow people to log in. Welcome to those who are joining. We're just going to give it another couple of minutes before we get started. Well, good morning or good afternoon. Just wanted to thank you all for joining us today. My name is Jessica, and I'm part of the team here at Accutive. So since it's 11:03 here in California, we'll go ahead and get started. Our agenda today will have a couple of brief introductions, and then we will have our special guest speaker, Davood Godes, talk to us about data masking and data encryption, followed by a demonstration by Dan Riberty of our Accutive Enterprise Data Masking Solution. So a quick overview of Accutive. We provide comprehensive information technology solutions, support, and services, including enterprise security and system integration to clients in industries such as financial services, healthcare, insurance, and more. And today, our webinar will be in the context of data masking and encryption. We're focusing on data protection and security. As I mentioned, our special guest is Davood Godes. And Davood has over 30 years of experience in senior IT roles, including CIO. In the past, he had served as the Chief of Office of Technology Services with California's Department of Technology, and he is currently the Vice President of Government Solutions at Direct Technology. Following Davood, we will hear from Dan Riberty showing us a short demo of the Enterprise Data Masking Solution. And if you do have any questions during the webinar, please feel free to submit them via the chat window. We will do our best to answer those questions at the end of the session, but if we can't, we will certainly get in touch with you afterward. So, without further ado, let's go ahead and hear from Davood.
Thank you, Jessica, and thank you everyone for joining us today as we talk about data masking and data encryption. I'm going to start by discussing some business challenges that we all experience in our day-to-day jobs. If you could go to the next slide, please, Jessica.
Yeah.
Some of the business challenges are listed on this slide, and I'll talk a little bit about them. Organizations today are faced with the challenge of ensuring the privacy and security of their customers' information while still successfully conducting their daily business activities. We all have been through those. There are regulatory compliance standards that we have to comply with for storing sensitive data, but then they must be followed. Examples of some of these compliance standards are PCI DSS, GLBA, HIPAA, FERPA, GDPR, and a few others. Organizations often copy or move sensitive data containing personal identifiable information and payment card industry information from the security of their production environments to less secure non-production environments, such as development, testing, or for third-party use. Data encryption is a common technique that's used for securing data in production environments, and we all use them today. However, since encrypted data becomes unrecognizable, unusable, and the formatting is not preserved, this is not the ideal solution for development and testing environments. In order to complement data encryption, there's an alternative, and that's data masking, which is the solution we're going to talk about during my short presentation and Dan's demonstration. Next slide, please. So how do you protect non-production data? While encryption is a common technique used to protect data in production environments, data masking is considered the preferred technique to protect data in non-production environments. An enterprise data masking solution has the following features. Information security departments right now deploy enterprise data protection solution for non-production data to meet these objectives. Data should retain its statistical properties, formatting, integrity, and realism of original data to allow for effective testing. Algorithms used by a solution cannot be reversible. The original data cannot be reproduced. The solution needs to be scalable and offer high performance to meet high volume testing of data sets. Logging and reporting is very important in order to track user activities to ensure controls and monitoring are in place. The solution needs to be repeatable and automated, and user access management must allow for segregation of duties between security administrators, database administrators, and application testers. Last but not least, solution has to have a lower overhead in terms of administration and management. Next slide, please. So what are the impacts of data breaches? The impacts could be fines from regulators, loss of market share, negative impact on your reputation. Despite the increase in awareness about security and privacy risks and increased spending on security solutions, organizations continue to fall victim to data breaches. Some of the recent large data breaches are the Equifax incident in July of this year, 143 million records. eBay in May of 2014 with 145 million users. Target in December of 2013 with 110 million customers. Accutive helps you protect and secure the data to avoid data breaches. You can see the rest of the organizations on that chart. So what is the cost of data breach? According to the 2017 Ponemon Institute Cost of a Data Breach study, the average consolidated cost of a data breach is $3.2 million. This cost covers the investigation, direct notification, litigation, redress and compensation, penalties, loss of productivity, and loss of business. So how would it come out per record? Per user, the average cost is $141. What are the major threats? They are insider threats, external threat actors, organizational data, and legacy systems. These are all threats, and we'll talk a little bit about each. Insider threats are standard users and privileged users. These are very real and difficult to prevent and detect. External threat actors like criminal organizations generate billions of dollars in revenue from data breaches and from other cyber crimes. Data within organizations with few controls, like unstructured data, exists on multiple end-user devices in multiple formats, and they could be a threat. Excluding mainframes, other legacy systems, and applications contain serious security vulnerabilities that oftentimes cannot be fixed and leave sensitive data exposed to cyber threats. So there is another option as a preventive measure in order to protect your data, and that is data masking. Next slide will compare actually the two together. So if we look at this chart row by row, under data encryption by default makes the data completely unreadable and unusable for development and testing. Whereas data masking, data maintains its original formatting. It is readable and usable for development and testing purposes. Data encryption requires encryption keys, which may be compromised. Data masking uses random data generation, and data cannot be reverse engineered. In data encryption, impacts performance. We all know that there's a performance hit with data encryption, and is time-consuming, especially when you encrypt large data sets. That's not the case with data masking. There's a high overhead, in particular with regard to the management of keys or certificates when we're talking about data encryption. In case of data masking, there are no keys or certificates to manage. There is a high acquisition and maintenance cost with data encryption, and there is a cost with data masking, but it's a lower acquisition and maintenance cost. So those are the differences and comparison of the two. Next slide, please. So why choose enterprise data masking? There are the following reasons. It reduces the risk of potential breaches through disclosure of sensitive data. It helps you comply with security and regulatory compliance regulations such as PII, PCI DSS, HIPAA, GDPR, and a few others. It creates fictitious data that retains field properties and is fully functional across multiple systems. Dan will show you how this is done. Refreshes and maintains masked data across different environments. And it is a repeatable, consistent, and automated masking operation. So in addition to data encryption, data masking is also a preventive measure to help protect your data. In conclusion, these are some of the benefits of data masking. I appreciate your time and your attention. Now I'll pass it on to Dan for the demo.
Okay, that's great. Thank you so much, Dawood, for that great information. And we really appreciate your time with us. And I will go ahead and make Dan the presenter. Thank you. So Dan, you may need to unmute yourself. Yep, there we go. And now you're ready.
Welcome everyone to our enterprise data masking demo. If I can just get to my screen here. Here we go. Okay, sorry about that. Okay, so this is our enterprise data masking front end. So if I just sign in here and we can have a look. what I'm going to start by doing is to bring up an existing configuration for data masking that I've created. The beauty about this is that data masking configurations can be created and saved, and then as your databases evolve, those configurations can be maintained. They can be modified to account for additional fields, they can be modified for additional fields or fields that have been deleted and resaved and then reused at will. As you notice here, everything is protected in the system with encryption keys. And if we take a look at my screen here, we have two sides. On the left-hand side, what I can see is for my database connection, I have my various tables here. Now, in order to save real estate space on the screen here, what we're looking at is all tables are showed here. Table names are highlighted, and all the fields within those tables are hidden underneath until I click on the arrow to drill down on each of those tables. So here we can see the various fields making up that table. And you will notice that the very first field on top, we have our primary key field, and then we have foreign key and various columns for tracking different pieces of information. Now, if we look on the right-hand side of the screen, we have the various fields that I have previously configured for masking. And if we take a look at that, we can open up the configuration for one of those fields. So the first field I opened is our primary key field. And if you notice here, the list of operations I can perform on a primary key is I can copy or truncate tables or update, delete, and so on. And also, one thing I can do is put a where clause on that field, and it's really standard SQL coding for those where clauses. And then I have my destination field here. So I'm going from my source to my destination database. If I open a second one, now one thing you will notice right away, this is not a primary key operation anymore, so my list of operations will change. And here's where I have countless different operations I can use to modify the data, to mask it. Some of these operations I can generate data, such as generate digits. I can generate credit card numbers or phone numbers or social security numbers, and so on and so forth. To further define how I will manipulate that data to mask it, I can also combine this with arguments, formats, and options. And what we can see here is, again, my destination field where once I've masked my data, where this data will land. And one more operation I would like to show you is if we look at the zip code operation here. So what I'm doing against the zip code is I'm going to generate a full address. One thing you will notice here is that I am using arguments of city and state. And what this operation will do is that it's what we call our smart address operation, and it will automatically populate my city and state fields, which can be seen on the left here, with the corresponding values for the randomly generated zip code. So if we have a zip code for California in the 90,000s, it will have the corresponding city and state to go along with that zip code. And as you will notice here, I do not have city and state that are part of my fields that I'm defining as being masked, because that's all taken care of from within my zip code operation here. One thing I could do also, I can go into view mode, and this will show me everything that I'm doing as part of this this configuration. All the masking operations I'm doing, my source tables and field names, as well as my destination table and fields for all the operations I'm doing. So I have address line 1, I'm generating an address, address line 2, zip code again, where I'm generating city and state, which will get populated automatically in these two. I'm using a constant for my country of USA, and I have generate dates that I'm using for my move-in and leave dates. Additionally, what I have is, and to note also, I could configure all these various other fields here in different tables for masking as well, but just to make it quick, I'm just dealing with one table right now. We can also generate a PDF out of this view screen here for purposes of tracking what's been done. So I can close this. Now, if we go take a look, I apologize in advance, we're going to go a little technical to show you before and after the masking. So we're going to go take a look in DB2, because what I'm doing here is a DB2 source to SQL Server destination masking. So we're going to take a look at our DB2 source database first to look at what data we have we're going to be masking. So if I do run my select statement again. And if we focused on the very first record here, so with a PKID of 55455, so we have a foreign key here, and we look at address line 1, which is 24 Sunset Drive. Address line 2 is the same. This is in the state of Michigan, Livonia, and country is spelled out, United States of America, and we have some rather old dates here. Now, if I go take a look in Microsoft SQL Server, and I look at the very top here, I'm highlighting the table which I'm querying. So if I run my query once more, I can see that my table is empty over here. Okay, so what I will do now, I will come back to my EDM, and I will run this masking. One thing you will notice over here is it's asking me to provide a name for the masking run I'm about to do. So I'm going to give it a name of DB2 to SQL Server with masking. And I'm going to get back to this, but there's a reason why we give our masking runs some names. So I'm going to OK this. And I'm going to give my encryption key. Save that. And now it's performing my masking. Okay, comes back. The masking was completed successfully. So if I close this, and now I go back to my Microsoft SQL Server, and I'm going to run the same query once more. Execute it. Okay. So now if I take a look at my very first record again with a PKID of 55455, I can see now I don't have 24 Sunset Road anymore. It's changed to Tomlinson Road with a suite of number 60, Orlando, Florida. And if you notice, the zip codes for the various states and cities pretty much follow, like for California, 95449, California, Hopland. So again, it's smart addresses, so the city and state will match the randomly generated zip codes. Country, it's not spelled out anymore. I have USA, and we have more recent dates out here. So all this to say that the data, the masked data we end up with is real, it's readable, it's usable, versus if it was encrypted data, we would not be able to read this at all. So it would all be coded. So the advantage of having masked data here is that it makes it easy to test for testers and also for developers to be able to relate to the data that they're looking at. If it was encrypted, there was no way to tell what is what. And if I go back to my DB2 data, so you can see where this data came from and how it was masked. And what we just performed here is an EDM source to destination masking. So we went from a DB2 database, our EDM engine queried the data, then masked it, and then, and then performed an insert or an update, depending on the type of operation we're doing, into the SQL Server table. Now, if we go back to my EDM for a second, I'm going to do a reset here of my environment. The next thing I would like to show you is the capability of running maskings with references. So if I load my configuration, rather than doing this, I want to show you how we create masking with references. So how we start the creation of a configuration. Move that aside. Open up the connection number 2. And I'm going to move that aside again. Now, I will open up my customers table. Same thing on the other side. And one thing I'm going to do is, so these are corresponding tables. However, they are in 2 separate databases. So one is in Microsoft SQL Server Ref 1, the other one is Microsoft SQL Server Ref 2, but it could very well be one side being DB2, the other side being Oracle or OpenEdge. So I can grab a field here and drag it to my desktop. Same thing with first name on the other side, drag it to my desktop. And what I'm going to do here, I'm going to link those 2 tables, those 2 fields, sorry, in doing so. So what this does is that it creates the reference link between my 2 fields. So as I'm going to be masking the data, it will mask the data in both databases, tables, and fields concurrently. So if I have John here and John here, as it masks the data, John will become Fred here, and correspondingly, it will become Fred over here as well. And what that does is that it allows me to keep the 2 masked databases in sync. And that's very important for some of the testing scenarios that we can encounter. So here I would give it an operation of generate first for generate first name, save changes, and here I would do the same, generate first. And one thing you will notice is that it added automatically a reference key name for me. And if the names correspond are exactly the same, then it's very easy. Otherwise, it will use the first one. If I go back and take a look at my configuration through the view window, so I can see here it added generate for first name. I have the operation generate first, and I have my reference key as first name. Now, in the interest of time, I just wanted to do this to show you how a configuration can be created. However, in the interest of time, I do have this configuration fully created, and I'm going to bring this up so that we can take a look at it, and then I'll be running it. So reference 1, reference 2, open that. Encryption key once again. Okay, so now I have fully created exactly the same thing I was looking at before, the same two databases. However, this is fully configured for me already. And that's, again, the beauty of being able to save and retrieve configurations. So if I go back into view mode, and now I scroll down to my customers table. So here are the operations I'm using against for reference masking. So generate first for first name, generate last for last name, generate digits. I mentioned earlier that we have the ability to generate data on the fly. So here's an example of it. So generate digits. I'm using 9 digits for this as my argument, 9. And I'm using a format also to tell it how the output should be formatted. And I have all my references on the side here. For a driver license number, I'm just using a constant and generate digits. I'm generating 10 digits. And again, I'm going to have a format. So this will format a phone number for me, like fully formatted. And one thing to note here is for my generate email address, I'm using an argument of first name, last name, and accutive. So 3 components that will make up this email address. So first name is exactly the name of the field over here. So what it will do is that it will randomize my first name and last name columns here, and then it will use those randomized values here to create a new email address for me using those randomized values. So that the data will match the actual first name, last name that it has here. And once again, as usual, we can generate a PDF out of this. So I'm going to close this. Now, sorry, I have to go technical again, so I will show you first, before I do my masking, I will show you first what the data looks like in the SQL Server table. So I have my Ref1 database here, and my Ref2 database here. So if I go take a look at my Ref1 database and run my query. Okay, so as my first record, the data that I have here already, I have Cynthia Kucha with what appears to be a social security number, her email address, along with what appears to be a valid driver license number, and the phone number, which is unformatted. If I go take a look in my reference to database and execute my query, I have exactly the same data. So Cynthia Kucha, social security number, her email address, driver license number, phone number. So that's what my data looks like before masking with references. Now I'm going to go back to EDM. I'm going to run this masking run. So start masking. Again, I have to give it a name. So masking with references. Encryption key. Save that. It's performing my masking right now. It'll take a few more seconds to complete. Here we go, completed successfully. So now I can close that. And now I can go back to my Microsoft SQL Server and let's go have a look to see what happened. So I'm going to go to my reference 1 database first and run my query. Okay, so before I run the query, so we notice we have Cynthia Kucha with her email address and all that. So if I execute my query, now that has changed after obfuscation, after masking, it has changed to Dhaka Barberia with her or his email address at accutive.com. Driver license, I had mentioned that I was using a constant, and phone number, I had a fully formatted phone number that I was using over here. And my social security number, I formatted it. I generated 9 digits, but I formatted it instead as a Canadian social insurance number. Now, this is performed with reference, so hopefully in the second database we'll have exact same data that was masked the same way. Execute this, and lo and behold, we have exactly the same data here. So first name, last name, with their corresponding randomized email address, driver license, and phone number. So if I go back to here, so this is just to summarize the process with masking with references. So we have 2 separate databases having the table with the same corresponding data. Oops, sorry. And as we run the masking, it will see John on this side, John on this side. The data will be brought into our EDM engine, converted to Fred, and then reinserted in the same location against the same PK ID. Fred reinserted over here. And as it does so, record by record, all this data gets tracked into a reference key file. So John becomes Fred. Now, this reference key file can be saved, preserved, and copied to another server or what have you. And as you need to perform the obfuscation against the same 2 databases, for instance, you have new production data you want to bring into your development or tester's environment, but have the data look the same to them so that they're familiarized with it. Then you bring back your reference key that you've used once, bring it back in your environment, rerun the masking, and the data will be the same, except it will be refreshed from production. If I go back to my server here and take a look, one more thing here that I wanted to mention is that as the masking is running, all the data gets tracked into an audit log. We also have an exception log if you encounter some errors during masking, and we have the obfuscate log, which tracks all the logic, like the connections being established to the various databases, and so on and so forth. So it tracks essentially the process of each masking runs. And if I take a look at my resources folder here, here's the reference.dat file that I was mentioning earlier, where it tracks John equals Fred and so on and so forth. So it'll keep track of all that data in here. You can copy that file, move it somewhere else, and do another masking for references with references for another purpose, and then play around with those files and bring them back or store them. One more thing I would like to show you, a very nice feature of our application, is the ability to go and take a look at database connections and have the application tell us which fields it believes to be suspicious as being PII data. And that's our scanning feature. So here, I just scanned one of my DB2 source. So it just went ahead and scanned that database. So table by table, so I can see my different table names over here, as I was seeing on the left-hand side earlier. However, it's opened up, it's broken down a little differently here. And here, all the fields that it suspects as possibly containing PII data, it will be highlighted in green, and it will have a check mark next to the field name. It does that analysis with 2 different algorithms. One is by field name. So if it contains the column name looks like something that could be suspicious as PII data, it will automatically flag it as PII. Or by data analysis. So if it doesn't find it to be suspicious by field name, then it will scan the column. It will take a sampling of about 100 records, and if it finds certain keywords in those 100 records, it will flag it by data analysis. And if I take a look at my employers table over here, so again, company name, email, company address, those are obviously all PII data, contain PII data. Industry was not flagged as such because it's something that's more generic. But I could go here and, okay, I know, I'm just using this as an example, but if I was the database administrator, I knew this did not contain any PII data, I could go and come and uncheck this field so that I don't see it further to be flagged as a PII suspicious field. So once I've made all my determinations here in my scanned database, I can go and action this. So right now the screen just disappeared. It doesn't look like it did anything, but if I go back and now instead of scanning, I open that database connection. Save that. Now it reopens my database connection, and one thing you will notice is I have an exclamation mark next to some of the table names. When we have an exclamation mark next to a table name, it means that within that table, some fields are suspected as containing PII data. So then, once I have an exclamation mark, I can focus on that specific table, open it up, and then all of the fields that the scanner had identified for me that had a check mark now are highlighted in green here, and it's then easier for me. I can focus on those fields and then grab them, drag them to my desktop, and start configuring them for masking. So that's the scanner for you. It's a very, very useful tool. Instead of having to go and take a look at all of the fields in all the tables, if you have a large databases that contains hundreds of tables and thousands of fields, this becomes very, very handy tool. Next, what I would like to show you is our dashboard. So now I'm opening up the dashboard. Now, if you remember, earlier I mentioned as I was starting masking runs, I had to name my masking runs, and here's where we can see those names come into play. So the last one I performed was masking with references, and if I click on this, it opens up, gives me the details of that masking run. So it gives me the connection name that was used, database connection name that was used, along with the start date and time and end date and time, along with the actual table that was masked. And again, specifics for each table, date and time, start and stop. So I have this for the masking with references that I just performed a few minutes ago. Then earlier than that, I performed a DB2 to SQL Server with masking, again, providing me with the connection name and database table that was masked. And earlier this month, I had performed SQL Server in-place masking. Same kind of arrangement. Next one is actually kind of interesting. I purposely caused it to fail by running the same masking run twice on a populated table to make it fail against the duplicate key on the primary key. So if I take a look at this, I'm going to see the failures that were returned by the application, and I can see the primary key where the failure occurred and the actual error that was generated by doing this. So what this allows me to do, and all this information is tracked by the application, and what this will allow me to do is the ability to rerun, once I correct the cause of the failure, it will allow me to rerun this masking specifically for those fields that failed. And also, if I take a look at a full masking here, so once again, I have all my table names that were masked, along with start date and times and stop date and times. if I go back to my, so just to summarize, with the EDM, we can perform source in place or source to destination or masking with references. And that's using a number of different database engines. So whether it's the database DB2 or Oracle, Microsoft SQL Server, OpenEdge, or MySQL. And that would be, for example, if I'm doing a source to destination masking, it could be from DB2 to Oracle or Oracle to MySQL, and essentially it can be from any database engine to any database engine. Also, our masking is very high performance. It's close to 100,000 masking operations per second. And also, in terms of preserving the integrity and repeatability, as we saw using the reference key, I can certainly rerun some maskings using my reference file that was generated previously, and it will come up with the same data once again every time. I can perform, in place or source, I've already covered. In terms of ability to generate data, we saw that with generating social security numbers or phone numbers. So I just need to tell it the number of digits I need to generate, and if I need a format or not, and it will do it for me. Our data scanner tool that I covered earlier. So as you saw, we can scan by field name or by data analysis. Very, very useful, especially when you have very large databases. I showed you also all the logging that takes place. So with the audit logs, exception logs, and the obfuscation logs. So it keeps track of everything, all activity that happens within the EDM. And having the ability to create configurations, and as your database evolve and changes, to go back to those saved configurations, modify them, save them, and rerun them as often as you like. That's a big advantage with that we have with EDM. And that concludes my demonstration, Jessica. So it's back to you now.
Okay, great. Well, thank you so much, Dan, for taking care of that for us. And I'm going to change myself back to the presenter now. Okay. So the demonstration was great, and I would just like to invite anyone that would like to submit questions via the chat. I have received a couple of questions so far, so if anyone else wants to submit, go ahead. And the first question that we received was, can this application handle flat files? And if we're talking about writing and reading data to and from flat files, the answer is yes, we can do that. So, and the next question that we have is about the performance. What is the performance like? Can it handle multi-million record data sets in a reasonable time? And yes, as Dan mentioned, we are currently processing close to 100,000 masking transactions per second, and we do expect that number to increase in our future releases. So yes, we can handle large data sets. So any other questions? If not, feel free to give us an email or visit our website, and if you wanted to follow up and get more information. But we thank you so much for attending. All right, thank you.